Hello, I'm Rodrigo, and in this video I will provide an introduction to MLflow. First, I will explain what MLflow is, then provide some basic terminology, and then describe some scenarios in which MLflow could help our research. After that, I will cover the very basics of how you would implement MLflow in your own code. Other videos to be released in the future will cover more advanced usage. MLflow is an open source platform that helps us manage the life cycle of our machine learning models, from initial experimentation and development to the final deployment stage. It was developed by a company called Databricks, which is also known for having developed Spark, which is a framework to work with computing clusters with implicit data parallelism. MLflow in its current version, which is 1.24, at the time of this video, offers 4 components. They are called MLflow tracking, which is the one I will actually focus in this video. This component allows us to record and query experiments. Another component is called MLflow projects, and this component helps us package our data science code to make the whole process reproducible, and it has integration with Docker. MLflow models is a component that I haven't explored so far. It's a component that allows us to deploy machine learning models in different serving environments. And finally, model registry allows us to store, annotate, and manage our models in a central model repository. MLflow provides also an API for Python and R, and is well integrated with the most commonly used machine learning libraries like PyTorch, TensorFlow, scikit-learn, among others. Now let's go over some basic MLflow terminology. First of all, a run is just an instance of model training. An experiment, on the other hand, consists of a set of runs in MLflow, and it's the primary unit of organization. Parameters are key value pairs, where the value can be a number or a string, and the key should be a string that represents the name of the parameter. The parameters usually represent, for example, hyperparameters of our model, or seeds for random number generation that are used to initialize the weights of our network, or partition the dataset into training, validation, and testing, and also references to input data. Then we have the metrics, which are key value pairs, but the value in this case can only be numeric, and they are usually used to quantify the performance of our model. For example, we could have L2 loss, mean square error, or accuracy logged as a metric in MLflow. Also, each metric can be logged throughout the course of the run, for example, every one epoch, or every one batch, or every a number of epochs or batches. And MLflow records these values and lets you visualize them through the graphical user interface. Then we have the artifacts, which in MLflow is the way they call output files that are associated to a run and can belong to any format. Typically, we want to log the weights of our model after training. But you can also log, for example, images or tabular data like CSV files. And finally, any other additional information that we want to associate to our run or our experiment can be logged as tags, which are also key value pairs. For example, if we want to log which was the computational platform that was used to run our code, for example Arc or your local machine, etc., you can log that as a tag. Or also you can log the name of the model that was used in that run, among other things. With all of this terminology at hand, we can now look at the MLflow user interface that we can utilize to explore our results. In this case, this corresponds to an experiment of my own work, which I named like this. And in this table, each row represents a different run, and we can see that we have different columns. Some of them represent metrics, some of them are parameters, and we have a single tag here. And aside from those columns, we have a set of columns at the beginning of the table which contain additional information of the run. For example, the start time of the run, the duration of the run. Also, the run can have a name, which I didn't assign in this case, but if I had done it, it would show up in this column. Then the user which performed the run, which in this case is myself. Then the name of the script that generated this run. And since each of these runs were executed within a Git repository, MLflow detects that and also logs automatically a hash that identifies the commit that corresponds to each run. This is particularly useful if we want to reproduce a previous run, since this column here identifies the specific version of the code that was used to produce these results. The user interface allows us to select the specific columns that we want displayed. For example, we may want to show a specific parameter of interest, for example this one, and a specific metric of interest, for example this one, and visualize only those columns in the table. Also, we may want to select a set of runs and compare the results for each. For example, let's take these two. This takes us to another part of MLflow, and since these metrics were logged for every batch during the training stage, we can, for example, look at the loss, at the evolution of the loss for each of these runs as a function of the batch in this case. We can also change the linear scale for a logarithmic scale. Going back to the main panel of the MLflow UI, we can run simple queries in order to filter our runs. For example, we can select all those runs for which this metric called loss was less than 1. And this returns a subset of all the runs that were originally here. If this functionality is not enough for us, we can always use the Python API for MLflow, for example in a Jupyter Notebook, in order to create more customized images or perform more sophisticated analysis. Now that we have seen what MLflow is about, I will discuss a few scenarios in which I think MLflow could be very beneficial for our research. These are not exhaustive, it's just a few cases in which I thought MLflow could be quite helpful. For example, the first scenario would be to explore our results. As we have just seen, MLflow provides a friendly user interface that we can access through a web browser. We can explore our results through this interface and easily find trends of specific metrics that we're interested in with respect to specific hyperparameters of our model. Another scenario would be to share our results with colleagues or our supervisors. For example, if we are logging our runs to an external server instead of our local machine, we can give our colleagues or supervisor access to our experiments, and they can look at specifically which hyperparameters we used for our runs, and in this way they would probably be able to provide better feedback and help us converge to a solution faster. Another scenario would be one in which we are executing our runs on different computing platforms. For example, they could be our local machine or AWS instances through Multics or the Arc cluster, etc. And in this case, provided that we are logging our runs to an external MLflow server, MLflow would provide a way to centralize our runs in a unique location from which we can query our results later. Finally, when we submit a manuscript, it would be possible, for example, to share a link for the reviewers to explore our results, and this would provide our work with more transparency during the peer review process. Now we will skip to the more practical part of this video. For this part, we will use a repository that is hosted under the Systib GitHub account, and it's called MLflow tutorial. But for now, we will actually use a personal fork of this repository that I have under my own account that contains additional material uploaded. You can see that this repository is private, but if your GitHub account is linked to the Systib account, you should be able to see both the repository under the Systib account and also my personal fork. First of all, let's clone this repository. Depending on your method of authentication to GitHub, you may need the HTTPS link or the SSH link. Since I have set up a pair of SSH keys for GitHub, I will use this link. Now we can use the git clone command from Git in order to clone the repository. Here I'm assuming that you have Git installed in your own machine. First I will cd into this folder to clone the repository here. By default, it creates a folder called MLflow tutorial, like the repository. So let's cd into this folder to examine the content. And we see that it has a Jupyter notebook. We will work with this one now. In order to be able to run the code here, we will need to install MLflow. We can do that using, for example, Conda. We can also use pip, but Conda takes better care of the dependencies. I have already done it under a Conda environment, so I will just switch to that environment. It's called MLflow in my case. So we can launch a Jupyter notebook and open the notebook. The first part of this notebook is the content that we have already gone through on the slides. Here we have some code to create a dummy experiment and a dummy run within that experiment, just to see if we have everything working properly. This line here should install MLflow using pip. I will skip it for now because I have already installed it, so I will just import MLflow. And here I'm importing some widgets library for Jupyter. This line here specifies the location in which I will log my MLflow runs. In this case, it's just a local folder that is called .mlruns. And here I will create, I will assign a name to the experiment. For this I use a widget there is a text box in which I can just write the name. For example, we can call it test. And in this line, I set the tracking URI using this MLflow method, set tracking URI, to which I provide as argument the URI that I defined above, which, as I said, is just a folder in my local file system. And then we fetch the name of the experiment from this text box widget, and we store it in the name variable. Then we can create the experiment using this MLflow method, and this returns an experiment ID that it's the one that actually MLflow uses behind the scenes. If the experiment already exists, then we instead of running this line under the try block, we will run this line that just gets the experiment ID given the name of the experiment, which we are assuming it already exists. In this case, the experiment, sorry, I need to run this cell. The experiment doesn't exist, so it's assigned the ID 1. And in this final line, we create a run within that experiment, which is again called test. It's initialized through this with statement using the start run method. To this method, we can provide the experiment ID that was returned here or here, and also we can provide a name for the run, which I'm assigning here. This is optional. As we saw before, we don't need actually to have a name for the run. And in this case, we are logging just a dummy parameter and a dummy metric. The parameter has as key the letter A, and the value is 1, and the metric has the name B, and the value is 2. So we will just run this cell in order to create a MLflow run. Now we can go back to the terminal and examine the content of the folder again, and we see that there is an additional folder, which is the one that contains the MLflow runs. So we can cd into it to see what's the content, and we see we have two folders here, 0 and 1. These folders represent the name of these folders represent the experiment ID. By default, we have already the experiment 0, and the run that we just created corresponds, as we saw on the Jupyter notebook, to the experiment ID 1. So we can examine the content, and we have a single folder here which has this hexadecimal string as name, which corresponds to the run which has performed. If we further go, if we further cd into it, we have again a set of folders for parameters, metrics, artifacts, and tags. Usually we won't need to dig into this folder structure, but we would rather use either the user interface, the graphical user interface through the web browser, or the MLflow API. So let's do that and use the MLflow user interface to explore this run. To do that, we just need to execute the command MLflow UI, and we need to provide an option here to specify the URI where we are logging the experiments. As we saw, it's this folder.mlruns. So we can go to the web browser and open localhost at port 5000, which is the default port for MLflow. And if we go to the experiment named test, we see our run that we just executed on the Jupyter Notebook with the parameter A and the metric B. We can now execute another run, but let's make it more interesting by logging an artifact here. So let's call it test with artifact. So I will try and log a text file as artifact. So for that I will first create a text file using this with statement here. I'm calling the file file.txt in write mode. So the text that this file will contain is this is a test, and we can log this file as an artifact using the log artifact method of MLflow. So if we look at the documentation here, we see that this method has a single mandatory argument, which is the local path argument, and this path should be a path to the file that we want to log as an artifact, right? In this case it would be just file.txt, so we can just copy this as an argument here. So it will execute this cell again, so we can go to the MLflow user interface and refresh it. So we can see that now we have another run in the table, and if we click into on this run and go to the artifact section, we have this file.txt artifact here, and we can examine the content, which is the text I just wrote into the file. This code here, even though it's very simple, should give you an idea of how you would implement MLflow in your own code using this MLflow API. It's just a matter of logging the different parameters of the model you are training and the different metrics in this way, and possibly some artifacts. So in practical terms, it would be just a matter of adding a lot of these lines to your code, but there are easier ways to do it. Actually, I usually code in PyTorch for developing deep learning models. In PyTorch there is a library called PyTorch Lightning that is built on top of PyTorch and provides a structured way to write PyTorch code, and with the associated benefit that for example, it's very easy to log model parameters and metrics. To see an example of that, you can go to the repository MLflow tutorial and see one example under the examples folder, which is for MNIST digit recognition. This is just a classification algorithm for MNIST digits. And if we look into this script, we can see it uses this PyTorch Lightning library that I was mentioning before, and in the main function of this script, we can see that the key part for logging parameters and metrics to MLflow is just a single line. So this is the only addition that we need to do to our code if we are using PyTorch Lightning as a wrapper for PyTorch.